database management system. So, what is database management system? It is a software that is designed to manage and organize data basically in a structured manner, and is also used in many industries and applications uh, like the healthcare industry. Now, what are the database models? Database model defines the logical design and structure of a database. It defines how data will be stored, accessed, and updated in a database management system. The important functions of it includes sets the rule, relationships, constraints, etc. to define how data is stored in database. It's basically it makes a blueprint of your database, types of data models that are used in database. So first one is hierarchical model. Hierarchical model organizes data into a tree-like structure where a single root to which all other data is linked. The hierarchy basically it starts from root data and expands like a tree where a child nodes are attached to the parent nodes. In this model, a child node will only have a single parent node. It also describes real world relationships like the index of a book, etc. IBM's IMS is based on this model where data is organized into a tree like structure. In this example, data is organized into a tree like structure with a one to many relationship between two different types of data. For example, one department can have many courses, many teachers, and of course, many students, as it is shown in the figure. And the advantages of it has one to many relationship between different types of data, so it is easier and fast to fetch the data. As in network model, data is organized like a graph and allowed to have more than one parent node. In network database model, data is more relationships that are established in this database model. Also, as the data is more related, hence accessing of the data is also easier and fast. Network database model, accessing of the data is also easier. This database uses many to many data relationships. IDS, that is integrated data store, is based on this database model. The network model is difficult to modify. We also want to explore this. If you are developing some social networking applications, although the graph database model is new and is far better than the network database model. The advantages of network model includes supports complex relationships. It also allows more flexibility. Then we have the entity relationship model. In this database model, relationships are created by dividing the objects of interest into entities and their characteristics into attributes. Here the different entities are related using relationships. Basically, here models are defined to represent the relationships in pictorial form to make it easier to different stakeholders to understand. The model is good to design database that can be turned into tables in a relational model as it's explained in the given example. Here let's take an example. We have a design we have to design a school database. Then the student will be an entity with attributes like name, age, address, etc. An address is generally complex. It can be another entity with attributes like street, pin code, etc. And there will be a relationship between them. Relationships can also be of different types. The advantages of this ER model is that is easy to understand and design. Using ER model, we can represent data structures easily. ER models can be directly implemented into a database model. It is just a step toward designing the relational database model. Then we have a relational model. In this model, data is organized in two-dimensional tables and relationship is maintained by storing a common field. This was basically introduced by EF Code in 1970 and it is been the most widely used database model. The basic structure of data in relational model is tables. All information related to particular type is stored in rows of the tables. Hence, tables are also known as relations in relational model. Some of the most popular databases are based on this database model. For example, the famous Oracle or what we use in colleges like MySQL, etc. The advantage of it is popular database software that is available for database model, and it is also simple and easy to implement. It supports SQL using which you can easily query the data. Then we have the object oriented model. Here data is stored in form of objects. Its behavior is just like object oriented programming. The very popular examples of it is ODBMS, uh, MongoDB, that can also that can also be a NoSQL database. This database model is not mature enough to become to the relational database model. Its advantages is easily support complex data structures with relationships. It also supports features like inheritance, encapsulation, etc. Then we have the NoSQL model. It supports an unstructured style of storing of data, and the data is stored in form of documents. The documents look more like JSON strings or key value based object representations. It provides a flexible schema as well. It provides features like indexing relationships between data, etc. And the support for data querying is limited in the NoSQL database model. This database model is well suited for big data like applications, including real time analytics, content management systems, like that. The advantages of NoSQL model is it is scalable, like you can increase the its workings. The database model functions with high performance. NoSQL database model can handle large volumes of data. Then we have the graph model. The graph model is based on real world like relationships, and here the data is represented in form using nodes or entities. The nodes are related using edges. The popular database Neo4j is based on graph database model. If your application has a simple data requirements, then you should not use the graph database model. In the modern applications like social networks, recommendation systems, etc., the graph model is well suited. The advantages of it is it handles complex relationships very well. In the modern world, where there is so much data and the data has to be related in different ways, the graph database model is very useful. Now coming on to database schemas. Database schemas basically refers to the logical and visual configuration of the entire relational database. The objects are often grouped and displayed as tables, functions, and its relations. So the importance of schemas in data modeling is the is as structural organization, where the role of schemas in organizing and formalizing the structure of data within a database system, and highlighting how schemas ensure the accuracy and consistency of data by playing a critical role in data integrity, which is also data integrity. Now it has three types. First one is physical database schema. The physical schema defines how the data or information is stored physically in storage systems like in the form of files and indices. The actual code or the syntax that is needed to create the structure design a database at a physical level. It's called a physical schema. Now after that we have logical database schema. Logical database schema defines all the constraints that are to be applied to the stored data, and also describes table views, entity relationship, and integrity constraints. And coming on to database schema, from the name we can get to know that it is basically used to define the interaction between end user and database. Here user is able to interact with the database with the help of the interface without knowing much about the stored mechanism of data in the database. So the components of a schema are attributes, and the attributes are the detailed insights of a role of the attributes and its significance within database schemas that emphasizes their contribution to data organization. And we have the data types. So here I have taken an example of student database where we have student. It has fields like name, student number, class, major. Here the primary key is student number. Then we have course, which has fields like course name, course number, credit hours, department, where there can be two identifiers like course number and department. And in prerequisite we can have course number, prerequisite number as the fields. In section can have the section identifier, course number, semester, year, and the instructor. Then we have grade report, where student number can be a primary key, and also two more fields like section identifier and grade. Now we have instances. So what are instances is basically the value of the particular attribute at a particular moment in time is known as an instance of the DBMS. And the application or explanation of instances in data modeling, including their real world significance and application. And we have another example where we have a single table student in database. Today, let's suppose the table has 100 records. So today the instance of the database has 100 records. Now we are going to add another 100 records of to this table by tomorrow. So the instance of the database tomorrow will have 200 records in the table. In short, at a particular moment the data stored in database is the instance, and this change over time as when we add, delete or update data in the in database. Now implementation of instances in data modeling. Application strategies. It is an in-depth exploration of methodologies and strategies involved in implementing instances within context of data modeling. The examples of instances in data modeling are real-world scenarios, financial management, healthcare systems, effective data analysis. Thank you.